Schneider Electric is proud to sponsor this podcast series. With a purpose to empower all to make the most of our energy and resources, our mission is to be your digital partner for sustainability and efficiency. At Schneider, we call this Life is On. Know more at se.com/au. My name is Jo Taranto and I'm joined today by Cameron Jackson, the Future Specialist Environment and Water at Urban Utilities. And today we're talking about using digital twins in planning for environment protection and livability. Cameron, thanks so much for joining me.
Thanks, Jo. Thanks for having me on the program.
Urban Utilities is one of the largest water and sewage utilities in Australia. Cameron, tell us about the work that you do.
So Urban Utilities has been around for about 12 years now, and we service population in Brisbane, Ipswich, and a couple of the rural councils to the west of us. And we operate 28 sewage treatment plants, and we distribute water to our customers.
And there's a lot of ongoing pressures on water utilities, isn't there? Can you tell us about a few of them?
Yes, well, we're in southeast Queensland, so everyone wants to live here. So our population growth is exploding. So we've got to work out how we accommodate and service the growing population. And that puts a strain on land use and getting the water supply to our customers from, which is normally a catchment supplied system in southeast Queensland.
And so Urban Utilities has this strategic goal of environmental leadership in the work that you do. Can you explain what that means?
Sure. So in around about 2017, we decided we needed to up the ante, and we put a line in the sand. So instead of increasing our emissions as the population grows, we decided that we would cap our emissions and aim for a long-term reduction. And so the strategy was brought in that is to protect and enhance our environment for the current and future generations. And we want to do that through excellence in water cycle management. So taking a bigger view and looking at integrated water management solutions instead of just focusing on our point source, which is our sewage treatment plant emissions.
And I know what a twin is, but you talked a lot about this idea of a digital twin for the natural environment. Can you tell us what that means and how you use that to help you in this environmental leadership?
Sure. So in southeast Queensland, we have a beautiful waterways, Moreton Bay, which is a marine park. So what we want to do is actually build a digital replica of all those waterways and Moreton Bay. So we can actually see on visualisations some of the impacts from the pollution loads from various sources on the system.
So it's almost like an online version of a natural ecosystem.
Yeah, that's right. So we build a range of models, and they model the catchment rainfall runoff. So when it rains, stormwater goes into the system. And we have our sewage treatment plants that also puts into the system. So we combine that into a model, and then we use some smart visualisation so you can see all that invisible pollution in the waterways and how it interacts where people might want to recreate.
And is your digital twin, is it fully developed? Is this system in operation now?
Yes, so we got approval to commence this project in 2019. It's a very challenging project, so it's still in development, but we aim ultimately to have 6 modules, and we've completed 2, and we're developing another one at the moment. So some of it's completed, and it's an ongoing project that we would think might run for another 2 to 3 years.
And once it's complete, what sort of things do you expect it to be used in all areas of the business, in particular areas?
Our first aim is to use it. We have licensed discharges from our sewage treatment plant, and in the Lower Brisbane River there's 9 of them. And we have a flexible licence that we can manage our emissions, mainly to improve the outcomes. So we want to use the digital twin to work out where would we spend our first environmental dollar to get the best benefit for the community.
Fantastic. And are you seeing examples of digital twins for the natural environment being used around the world or in Australia?
Yep. I think that's a growing area of water utilities and integrated water management. So there's a couple of good examples where digital twins are used. and are in operational use, and that is SafeSwim in Auckland in New Zealand. So they use it to manage recreational water quality. So if it's polluted, they warn that you can't go in. And over in Sweden, in Gothenburg, there's a future city flow system that DHI, who are our project partners, have implemented over there, and that uses a forecast system to manage sewer system operations. It's pretty cool.
You're listening to the Australian Water Association podcast series, and I'm speaking with Cameron Jackson from Urban Utilities. It sounds amazing, and it certainly, you can see that there's a huge variety of applications as well. Do you think that this will be something that other utilities will be very interested in if they're not already on the journey?
Yeah, we've spoken to some of the other water utilities in South East Queensland. Because Moreton Bay, that we're modelling our regional, our neighbours, councils and water utilities were interested to also get involved. So we hope ultimately that what we build can be a sharing collaborative platform where other utilities and councils can use it, and they can manage stormwater, we can manage our point source, and we hope to also engage with the regulator. So maybe the regulator can use it as a tool to help set in licence conditions. And
fantastic. And obviously for future planning and operations, does it have a lot of applications?
Yeah, we've built a planning tool. So what that means is we're looking at a hindcast. So we're looking backwards when we build it. And then we can see how the system performed based on historical events that might have occurred. And that allows us to see the impacts of our current or historical operations. And that can feed into our future planning, so we can try and mitigate where we might be having the greatest impact. In the future, we will move to a nowcast. So that means that it's running live, so you can actually look at the digital twin, and it should be replicating what's flowing down the river at this time. And then after that, it runs into a forecast. So that future city flow uses a forecast of the weather. And if it looks as though it's going to rain, it proactively manages the system before the rain comes to try and lessen the impacts.
And what's next for this model, for the digital twin? Is it completing it and fully implementing it, or have you got bigger visions than that?
Yeah, so we hope to incorporate it into our environmental reporting. And the first step of that's going to be what we call an environmental footprint. So at the moment, we don't know exactly where our environmental footprint is on those waterways. We just have a licence that allows us to put a certain amount of wastewater into the river. So this digital twin will show us all the environmental footprints, and then we can work out which one should we mitigate first. So it really provides a cost-effective way of getting your best bang for buck on environmental improvement. And the second part of what we're doing, which is the effects-based planning, we can run different scenarios. So that means that we can change where an outfall might be, or we can improve the quality of the effluent that's going out that outfall. And before we invest to do it, we can use the digital twin to say, well, what impact would that have on the system? Are we getting the benefits that we think that we would get? And the benefits could be it allows swimming at a certain beach, or it might stop an algal bloom, or the potential for an algal bloom in an area that people like to recreate at. And so before we invest, we know we have high confidence that we're going to get those environmental and livability outcomes.
Cameron, can you tell me a bit more about how all these models work together?
Yeah, well, we discovered that the Port of Brisbane use a hydrodynamic model. So that's a model of all the waves and the currents in Moreton Bay, and they bring ships into port using the models because it gives them the underkeel clearance, which so they don't run aground in the shipping channel. And we have a good relationship with the port. They're one of our key customers, and we said, well, why don't we bolt a water quality model onto your hydrodynamic model? And so we arranged commercial access to their model. And so then the second part of the models was the catchment rainfall and runoff. So this is all when the rain falls, it hits the surface, could be a house, could be a forest, but it still all runs off and goes into your local creek. So we've built a model that allows us to calculate the pollutants that come off the landscape and into the creek. and then we plug that into the water quality model. So each creek, we know its pollutant load, and then we also know our point sources. So that's our sewage treatment plants, and they discharge into the river every day. The model, the hydrodynamic model, then calculates where all that flow ends up in the system. And the water quality model then tells us the concentrations of the pollutants in the system as it all mixes. So it's all complicated. And then we put that through smart visualization software that then shows it on a screen in an easy to see format. So you basically just play a video and you can see these pollution plumes going up and down the river on the tide and as the wind blows it. So it's quite complex, but when you see the finished product, it's actually quite a simple, and we hope our customers and people we can engage with can easily see what we're talking about, and you can see the impacts and the footprints and stuff like that. So that's good.
Is there a limitation to the sorts of pollutants that you can measure or track?
Yeah, well, there's the Moreton Bay study, which was a big report done around 1999, provided in-depth details to what the stresses were on Moreton Bay. So we use those pollutants. They're still current today. We've probably got more of them because the population's grown so much. So it's just standard ones like nutrients and salinity and turbidity and sediment and normal ones that impact waterways around the world, really.
You're listening to the Australian Water Association podcast series, and I'm speaking with Cameron Jackson from Urban Utilities. Cameron, what does this digital twin look like? Is it literally a map with sort of a traffic light system, or is it graphs? Can you tell us, for those who can't see it, a little bit about what it looks like?
Yeah, so basically it's like you're in a plane and you're looking down on Moreton Bay and the whole river, and then the plumes are shown in various different colours, like a contour map. So red might show you where it's most polluted, and then goes through orange, yellow, and to green. And then the Department of Environment sets water quality objectives for our waterways. And so what we can do is we can see which parts visually of the bay are exceeding the water quality objectives, and therefore the regulator will want us to try and reduce those pollution plumes in those areas back down to the level that they desire. And so the digital twin will allow us to look at that aerial view and go, okay, in our normal operations, we're having impacts in maybe these 2, 3, 4 areas. And then we can go away and do some planning to think, well, how can we actually reduce it? Do we upgrade a sewage treatment plant? Could we do some work in the local creek because it's actually the creek that's causing the problem? And we've never known this before because everyone just thinks it's the sewage treatment plant is the cause of all problems. But this new system might show that it's actually just normal pollution coming out of a creek. So can we work with a local creek catchment group and the community and let's improve the creek condition? It could be soil erosion from the bank of the creek or something like that. And that's where you get a better bang for buck, because in the past we would have just upgraded the treatment plant and then the residents are still going, but I've still got the same problem. Okay, so that investment might have been a bit of a waste of money. So this will allow us to target where those key problems are.
I've been speaking with Cameron Jackson, the Future Specialist for Environment and Water at Urban Utilities. Thanks so much for your time, Cameron.
That's been great. Thanks for having me on.